Hello, Mrs. Leganke here, going over some volume formulas with you. It says for number 1, what do each of the variables represent in the equation that you see? So V, right here, V stands for volume. You know, that's how much something would hold or contain. And then notice that the B is capital B. We've talked about this in class. The capital B stands for the area of the base. Okay, so that's an important distinction. It's a capital B, so that's the area of the base. And then the letter H, you probably know, that stands for the height. So that's the distance between the base, from the base to the top. Okay, so this formula here can be used for a lot of three-dimensional figures, but we usually use this one for a rectangular prism or a cube. I'm just going to say prism. Okay, next it says to sketch this figure and label it with dimensions you choose and then calculate the volume. So let's go ahead and sketch a prism. So to sketch a prism, begin by creating a rectangle and then an overlapping rectangle that's similar in size, and then you're going to connect the vertices there. Okay, so there's my prism that I sketched, and yours probably looks better than mine. Let's go ahead and put in dimensions of our choice. So I'm going to pick something that's kind of easy to do. So I'm going to do the maybe 8 here for the length, 6 for the width, and I'll make the height 4. Okay, so I'm going to then calculate the volume. So I write down the formula, and then I substitute into the formula. So the base here is a rectangle. To find the area of a rectangle, remember this means the area of the base. We do length times width, and then I'm going to multiply that by the height. Okay, so I'm going to go the length times the width times the height. So 48 times 4 is 192, and then I can say units cubed, or cubic units. Okay, and you were allowed to choose dimensions, so if you want to change those, you can. Okay, moving on to using the formula below to answer question 4 to 6. What do each of the variables represent? So looking like we have a capital V again. Remember the capital V stands for volume. Then we have pi, which we can estimate as 3.14, or we can use the pi key. But the next variable is r, and that stands for the radius. And just as a reminder, the radius is the distance from the edge to the center of the circle. Radius is half of the diameter. So radius is that from the middle to the edge of the circle. And then the last variable that we have is the h. And h, just like in the last formula, stands for height. So question number 5 says, what three-dimensional figure is this formula used for? And since I see pi r squared in there, this is going to be for a cylinder. Question 6, now we're going to sketch a cylinder and label it with the dimensions that we choose. So remember, when we sketch a cylinder, we do those like kind of 2 ovals of the same size, and then you're going to connect. Okay, so there's my cylinder. I'm also going to include my radius, so the center to the edge of one of the circles. Okay, so that's where my radius will be. And I'm going to put in dimensions that I choose. So I like to keep it simple just because we're practicing. I'm going to go with a radius of, let's say that the radius is 3, and then we'll make the height be, let's go with 6. Okay, now we're going to solve this. Okay, step 1, here I'm going to copy down the formula, pi r squared h. And now I'm going to substitute in the radius, which is 3 squared, times the height, which is 6. And my first step, I'm going to hold off on pi. I'm not going to calculate my pi yet. So just leave pi in my answer. All right, exponents first. 3 squared is 9, because that means 3 times 3, and 9 times 6 is 54. Okay, so I have, in terms of pi, I have 54 pi. And then if we're going to actually calculate using pi, I'm going to go ahead and use the estimate of pi, which is 3.14 times 54. And then when I multiply that, I'm going to write it over here, I'm going to get 169.56 cubic units, or units cubed. Okay. Okay, and for the last part, you're going to think of cake design, and you are in charge of ordering a cake for your friend's party. Yum. And Cassie's Cake Company offers 3 designs. So look at the different designs, and they're all for the same price. So we want to get the most cake for our money, I would think. We want to find the greatest volume to see what cake we should buy. So, you know, right away, I'm kind of drawn to this cake here. I think kind of like the cylinder shape. But of course, it's style preference, and we want to see how much volume each cake will have. So, design A, do you see the 2 shapes? We have, right here, we have a rectangular prism, this bottom shape right here, and then we have a cylinder up top. So we want to do the volume of each one. Okay, I'm going to start with the rectangular prism. And remember, that was the area of the base times the height. So looking here, I'm going to do the base, the area of the base. It's a rectangle, so I'm going to do 14 times 12, and then times it by the height of 7. Okay, so for the bottom piece, so 14 times 12 times 7 is 1,176 inches cubed. I'm going to go ahead and write that right in the cake. Inches cubed, okay. And then let's find the volume of the cylinder, this piece up top. And that, if you see on your formula, on your sheet here that we used, is pi r squared h. So V equals pi times the radius, which is 5 squared, times the height, which is 6. I'm going to go ahead and use the estimate of pi, 3.14, times 5 squared, which is 25, times 6. So let's go ahead and calculate all that. 3.14 times 25 times 6, and I get 471 inches cubed, and I'm going to write that right in here, 471 inches cubed. Okay, so now all together, how much volume is this cake? We're going to add these 2 numbers together. So 1176 plus 471. So this cake 6 is 1,647 inches cubed for its total volume. Okay, let's move on to the next cake and see how big that one is. Design B are both rectangular prisms. Okay, so we want to do, so the area, the base, times the height. We're going to do this twice. So I'm going to start with the top piece. Okay, so it looks like it's 8 by 8 by 6. So 8 by 8 by 6. 8 times 8 times 6. So 384 for the top piece. Cubic inches, or inches cubed. I'm going to write that right inside the cake. Okay, and then the bottom piece, let's see, it is 13 by 10 by 6. So 13 times 10 times 6, which is 780 cubic inches. 780. Okay, and then to get the total, we're going to add those two together. So this seems kind of small compared to the last one. Let me see. 1,164 cubic inches for this one. Okay, wait, let me see what the last one was. Yeah, this one's a little bit smaller. So far the first one is in the lead. Okay, and design 3, which I liked from the beginning, I liked the cylinder shape. Just seems a little fancier to me. So a cylinder, the formula was pi r squared h, and we're going to have to do that twice. Okay, so I'm going to do the top, the smaller one first, this one right here. Okay, so we're going to do pi. I'm going to use 3.14 for pi just to estimate it. The 3.14 times 6 squared times the height of 3. Okay, so this is 36. So 3.14 times 36 times 3. And we get 339 and a little bit here, 0.12. Okay, inches cubed. So I'm going to write that right here. Okay, so that's the top piece. So the bottom piece looks much bigger, so let's see what we get here. I'm going to use 3.14 for pi, and 8 is my radius, so 8 squared times the height, which is 5. So this is 64. So 3.14 times 64 times 5. All right, and that is 100 or 1,004.8 inches cubed. Okay, and then the last step would be to total that up. What's the total volume for this cylinder shaped cake? So add that up. Okay, let's see. 1,343. Oh, I forgot to write. I wanted to write this measurement in here. I don't know. I just like writing that in there. Okay, so now let's see. Let's compare and make our final statement here. Which cake we're going to go with. Okay, so now there's a little space there to write down all of their total volumes. And, well, if I have to choose to get more cake for my money, I'm going to have to go with choice A. Now, I do like the look of design C, and that would be the second greatest volume, so I could justify that I would want that because I like the look of it. But if I'm being asked, like, more cake for my money, I'd have to go for design A. So you go ahead and write your response here and why you would choose that answer. So something like, I should order design, and then you choose and tell us why. Okay, thank you.